By the summer of 1900, the United States population surged past 76 million people. That massive labor force was fueling a rapid, sprawling economic expansion, turning quiet towns into crowded industrial hubs. But all of that new domestic commerce was severely bottlenecked by the logistics of moving goods. If you look at a typical street from the era, you see the problem: heavy reliance on slow, horse-drawn carriages navigating rigid streetcar tracks. The rail network offered a partial solution. Steam locomotives could move thousands of tons of cargo quickly, but they were entirely inflexible. Commerce was strictly bound to predetermined linear steel routes, leaving large portions of the country isolated. A hint of a different transportation model appeared in November 1900 at Madison Square Garden. The first automobile show held in the United States filled this exhibition hall with trackless, self-propelled vehicles. At this point, these machines offered no real logistical value. They were artisan-built novelties, crafted by hand for wealthy buyers who wanted a luxury status symbol rather than a reliable tool for trade. To truly modernize, American producers needed to break free from fixed tracks and move goods directly from point A to point B. In 1900, bridging that logistical gap remained a theoretical challenge rather than a practical reality. The physical limitation of trackless travel required a dense, cheap source of power. In January 1901, drilling crews at Spindletop in Beaumont, Texas, struck a massive reserve of petroleum. That single discovery provided the abundant fuel supply necessary to power internal combustion engines at scale. With cheap energy secured, engineers spent the next 2 years testing exactly what these combustion engines could achieve. The year 1903 delivered the crucial proof of concept. In July of that year, an automobile completed a journey from San Francisco to New York. The 63-day trip proved that a trackless vehicle could physically survive thousands of miles of rough, varied terrain across the entire continent. A few months later, Wilbur and Orville Wright applied that same internal combustion power to a much more difficult logistical challenge: achieving heavier-than-air flight. On December 17th, at Kitty Hawk, North Carolina, their petroleum-powered engine successfully propelled their biplane 120 feet in 12 seconds. By the end of the day, they were covering over 800 feet. These 1903 milestones proved the mechanics of flight and cross-country driving were viable. Yet, because every car and plane was still meticulously crafted by hand, neither machine could meet the massive logistical demands of a nation with 76 million citizens. This diagram illustrates the core economic bottleneck. On the left, artisan crafting yields a single high-quality unit over a long period. On the right, massive consumer demand remains unmet because manual labor cannot scale. By shifting to an assembly line, the workflow is fractured. Standardization allows workers to repeat specific tasks endlessly, dramatically accelerating output to satisfy demand. Henry Ford recognized the automobile would only become a viable tool for national commerce if it could be manufactured using these precise, divided labor techniques. In September 1908, his Detroit plant achieved an operational breakthrough. Workers abandoned handcrafting individual vehicles and instead stood at stations, mechanically lowering standardized car bodies onto moving chassis. The immediate output of this new industrial system was the first mass-production Model T. By standardizing every bolt and frame, the factory could produce vehicles at a fraction of the traditional cost and time. Henry Ford's system integrated existing technologies like the internal combustion engine into a workflow that transformed a rare luxury into a tool for the masses. This change turned the automobile from an experimental novelty into a scalable commercial asset. As thousands of standardized vehicles rolled out of factories, they immediately collided with the reality of America's primitive terrain. Cars frequently bogged down in deeply rutted, muddy rural paths that were never designed for heavy mechanical traffic. The sudden influx of affordable Model Ts forced local and federal governments to adapt. They could no longer rely on packed dirt trails. They had to construct dedicated, reliable infrastructure to support this new weight and speed. In October 1908, the U.S. Bureau of Public Roads completed its first initial test of a hardened macadam surface through the Cumberland Gap, binding gravel with liquid asphalt to create a durable commercial artery. Aviation hit a similar commercial threshold that same year. In the spring of 1908, the Wright brothers successfully carried their first passenger. That shift from solitary experiments to shared transport demanded the future construction of dedicated runways and organized airspace. This shifted the national logistical map. Commerce moved past rigid railroad tracks and the slow pace of horse-drawn carts, expanding into a web capable of moving goods rapidly in any direction. The true legacy of the 1900s lies in the transition from prototypes to production. By building the mass production systems and physical infrastructure to support these machines, engineers integrated them into the permanent foundation of modern trade.